This is a video on checksum hashing, a simple idea. This is again a video on practical ordered hashing. Here we have a key of length, binary key. We wish to map, again as always, whenever you are trying to generically solve problems of this kind, such as, it is best to adopt certain fixed conventions so that you're always clear. So our objective is to map a number from 2 power L dash to S equal to 2 power L. So we wish to perform the coding from M to S, where L dash is significantly much larger than L. And the coding has to be such that, given a key K which belongs to M, if it is mapped to a hash value V which belongs to S, it is order preserving and also very much compressing, so that it can be served for both database hashing as well as for data compression. When I talk about compression, I mean quite a large amount of compression, not of the order of that is generally postulated in this theory possible by according to that theory, which is basically false. Now, so here all it takes is, the idea is a simple one. You have a key K L dash. This is the 0th bit. This is the L dash minus 1th bit. These are all the individual bits. So what here you do is, it is based on the observation. If you take the bit position of all the sum of weights, it is based on the following fact, or observation of the following fact. What is the sum of all the, let us assume that L dash is even. So L dash minus 1 will be odd. So sum of the weights of the even positions equal to half the sum of the weights of the odd positions. So what you do is, if you have a large key K, you split the key is now split into two parts equal to all the bit positions in the even locations and all the bit positions in the odd locations. And then, so if you wish to hash a key K, let K naught be the key obtained by taking all the bits in the even bit position, and K1 be the key obtained by taking all the bits in the odd bit position. Then this can be written as 2 times h of K1 plus h of K0. So basically, for a large length key of large L dash, the second invocation is for a length of L dash by 2, but only twice. But since the weights of the odd locations is always twice that of those in the even locations, therefore you multiply for the odd location by 2. You can recurse this to any length. Now if the length L dash is taken to be 3 and key is split into 3 parts, those K0 is equal to positions, all bit positions whose mod 3 value is equal to 0. K1 is equal to all bit positions mod 3 is equal to 1, and K2 equal to all bit positions mod 3 equal to 2. So now the hash value will simply become 4 times h of K3, 4 times h of k2 plus 2 times h of k1 plus h of k0. In other words, will this be order preserving? Yes. Is the computation required for this very, very small? Yes. And is it very much data compression, offer data compression? Yes. So you can see that we can write compression, checksum compression hashes. Can this be used for checksum compression? Yes. Can this be used for database access, ordered database, instantaneous ordered database access? The answer is yes. All of this it can be used for. But primarily it is good both as a checksum hash as well as this is a practical checksum hashing. So there are different ways we saw earlier also another. So now we also know that if k is any or n is k is any key value, then nth root of k or log of k to the some base b will be less than, will also be fairly unique and at the same time also order preserving in that sense. So what we can do is we can reduce the key. For instance, if we wish to compute a 32-bit hash value, we could possibly divide the key as bytes or something. We could divide it into as much as 8 parts itself. 2 also is fairly sufficient. So for a fairly large key also we can divide it into 2 parts, 4 parts, 8 parts or whatever. And then only at the base case we can use say something like log, or we can come up with something which is more probabilistically in keeping with the distribution of numbers, which is bearing in mind the bell curve. So here you can just have, you need to have log to the base b of k you could take, or you could take the nth root for the last base case. So it is based on just this. So it's again an illustration of the general problem solving technique. That is, you solve now for one case where you split the key to binary, you can extend it to more than that. So this is another example of ordered checksum hashing.